What did we do yesterday?
We learned about drift velocity. Drift velocity, which is represented by Vd. We learned that is the the velocity with the charge will move from one point to another with respect to time.
Okay.
Then we also learned about relaxation of time, which is represented by tau. We also learned that Vd is we also learned that Vd is tau by t. Then we learned that the relaxation of time is the time taken between two successive collisions of the electron in the electron C model, whatever is then then after that we derived an equation saying that drift velocity is equal to the drift velocity is proportional to the relaxation of time. After that, we also learned that the electric field is directly proportional to the drift velocity. Then we derived an equation I remember till this.
Sir, I have a doubt.
What?
So we derive the formula J is equal to NE square tau by 2m into E, right? There we took Q is equal to only E. Why didn't we take it as NE? No, Q is NE, right?
So similarly, what we did, we already have taken there for group of electrons, n electron volume. So there we have already considered that there are n electrons. So Q will be charge of one electron only. N, the density, electron density, we have taken already n electrons per unit volume, right? So we have already taken n. Now it's only we have to multiply with your charge of each electron for that. Okay.
Yes.
Now I have ended with something called as electromotive force, EMF, represented by epsilon. I said EMF is the potential difference between the terminals of a battery or the cell when there is no external resistance connected to the circuit. So basically EMF will be equal to your potential difference when there is no external resistance connected. And please understand, potential difference is between 2 points in a circuit. Okay. So when we were doing, we said the potential difference between this and this is V1 and this is V2, right? We did not use a term called as EMF, right? So potential difference is like, the potential difference is between 2 points, okay? EMF is exclusively used to a cell or a battery. When you say EMF, that means you are talking about the power source. Okay, when you say potential difference, it means you are talking about the potential difference between 2 points in a circuit. So that's your basic difference between potential difference and EMF. If somebody asks you Will your potential difference ever be equal to your EMF? You say, of course, it will be equal when there is no external circuit connected. When there is no external resistance connected, your EMF is equal to your potential difference. Clear? Now, what is the energy produced in a resistor? See, I'm going to take a circuit. I'm going to put an external resistor. And this is your EMF. And this is your R. So the current comes out of your positive terminal, will go in this direction, will enter into your resistor, and again will come out. Right? This is how current goes, isn't it?
Yes, sir.
The direction of current, please remember, is from positive terminal to negative terminal inside the circuit, and inside the cell it is from negative to positive, which is the opposite when we do the semiconductors. Okay, so for you right now, it is a conventional current direction, because previously people thought there was something called as positive charge also. They thought flow of positive charge is current. Okay. So, but then later they found out that there is nothing called as positive charge. Absence of negative charge is positive. That's all. Clear? So, in this direction, it is going inside. Now, I need to calculate the energy produced in a resistor. Right? When there is a potential difference V between your resistor and there is a charge Q going through this resistor, can I say the energy is Q into V? Energy supplied by battery. Q into V, no? Potential is equal to work done by charge, right? So can I say W is equal to QV, and work energy, we already know your work is nothing but energy. So energy is equal to Q into V. Yes. So now the potential difference between your resistor, according to Ohm's law, your V is nothing but I into R. So your U will become Q into IR. Okay. Now Q, I know my I is nothing but QE. So from that, Q is equal to I into T. So I substitute I into T here, and this will be I into R. So this is I square RT. Clear? So this energy which is produced in the resistor is in the form of heat energy. That's why we call it as energy. The energy in your capacitor is I square. Huh? The energy in your capacitor.
Half epsilon.
Capacity.
E square. Half epsilon not E square.
Energy stored
Half Q.
Half Q square C. Half QV square is equal to half QC, QV.
right? So there I said energy is stored in the form of electrostatic potential energy. Here the energy produced in your resistor is
Thermal.
thermal energy or heat energy. Now, see, I'm going to take this T up. This will go into your formula. Now, from U is equal to I square RT. I'm going to take my T to the side. It will become I square R. Right? So, U by T is power is equal to I square R. R, if you put R is equal to V by I, it will become VI. Or if you put I is equal to V by R, V square by R. So the power of a resistor is I square R or VI or V square by R. Clear? Once again, the energy stored in your energy produced in your this one resistor is in the form of
Thermal energy.
energy. Clear?
Yes, sir.
Next, put your heading as Kirchhoff's law. Kirchhoff's laws. Kirchhoff's Kirchhoff's laws. This guy is a Russian scientist, Gustav Kirchhoff. Okay. So he said whenever there is a complex circuit, okay, see right now you put a battery, you put a resistor, it's a simple circuit, you say current is going like this, single direction current. But what if you have a complex circuit? Okay, for example, there is a resistor like this, there is a resistor like this, and there is a resistor like this. Part of a complex circuit. This is a branch of a complex circuit. In this case, if there is a current I1 coming from this direction, there is a current I2 from this direction, there is a current I2 leaving this, and there is a current leaving this. Okay. So this is R1, R2, R3, and R4. Now, somebody asks you, can we relate I1, I2, I3, and I4? Okay. Normally, what you would do is, suddenly, you will be terminals first. Correct? And then what terminals will connect the battery, and then you say the current goes out of it. Now, instead of doing all that, what your Kirchhoff said is, leave all that happening. Okay. If whenever you see a junction, please understand that algebraic sum of currents entered the junction will be equal to currents leaving the junction. So Kirchhoff's first law is your junction law. Kirchhoff's first law is called as your junction law. So what this guy says is, whenever you see a junction, please understand the summation of currents entered the junction is equal to of your currents leaving the junction. Clear? Plus I2 will be equal to I3 plus I4, isn't it? Or the total current at the junction will be equal to 0. You can take this plus I square is equal to 0. Right? Clear? Clear? So junction law, the algebraic sum of currents entering the junction will be equal to the algebraic sum of currents leaving the junction. This is what your junction law is. So you can take your currents coming towards your junction as positive and currents leaving the junction as negative. Okay. Junction law, your sign convention will be currents towards the junction positive, currents away from junction is negative. This is the sign convention which you will follow for your junction law. Clear? Understood? Next, put your heading as loop law. Loop law. The algebraic sum of all potential differences. The algebraic sum of all potential differences. Algebraic sum of all potential differences along a closed loop. Along a closed loop. Along a closed loop in a circuit is 0. In a circuit is 0. That is sigma b is 0 or sigma epsilon minus I into R is 0. I into R. R is your internal battery. Clear? Any doubt in this? Now see, take a closed circuit, take a battery and a resistor, battery and a resistor. Okay. R2, R3 and R4. This will be your epsilon 1 and this will be your epsilon 2. Okay. See, this is just a part of bigger complex circuit. Clear? This is just a part of a bigger complex circuit. It is forming a loop. In that bigger complex circuit, this alone is forming a loop. Clear? Now I want the directions of my current. Let's take an arbitrary directions. I'm saying direction of current I1 is in this direction. Current I2 is in this direction. Okay. I3 is in this direction and your I4 is in this direction. Clear? Name the loops now. A, B, C and D. Now I said The algebraic sum of the potential differences in a closed loop is equal to 0, right? So A and B, what is your potential difference? VA minus VB. What is your potential difference? I1 R1. Potential difference between A and B, Amma. I1
Yes,
R1.
sir. Yes, sir.
Potential difference between B and C.
I2
I2
R2.
R2
I2
R2.
R2.
right? Now see, this, there is a cell here, there is a battery here. So from here to here, what will be your potential difference? I'll do one thing. I'll take this point as C dash. Okay. So VC minus VC dash will be how much? Okay, take it down. I'll tell you the sign convention later. Okay, it will be minus epsilon 1. Then VC dash minus VD will be how much? Right? Now, this point which is, I'm going to take it as D dash. So VD minus VD dash will be how much? Minus I4 R4. Okay, I'll tell you why minus. Okay, just take it down. So V dash minus VA is how much? It will be positive norm 2. I'll tell you why. Take it down. If you add all these things, what happens? Minus minus VA and everything goes to 0.
Yes, sir.
So I1 R1 plus I2 R2 minus epsilon 1 plus I3 R3 minus I4 R4 plus epsilon 2 will become 0. Nothing can be applied for your capacitors. Now you try to solve your capacitors using your junction law, will feel very easy. Okay. Now let's come to the direction, the sign convention of it. In a very simple sense, I'll tell you the sign convention. Blindly follow it. Potential drop, you will take it as positive, and potential rise, you will take it as negative. Now let's understand what do you mean by potential drop and potential rise. See, object is greater than VB, that's why your current is going from A to B.
Yes, sir. Yes, sir.
Here VA is greater than VB, so the current is going from here to here, right? Now come from here to here, right? VB is greater than VC, hence your current is going from B to C. Come here, this is negative, this is the positive terminal potential is greater than the negative terminal potential. Potential of positive is greater than potential of negative, isn't it?
Yes, sir.
So you are going from where? Potential drop or potential rise?
Potential drop.
Rise, drop or
Yes.
rise you are going, no?
Yes, sir.
That's why you have taken minus I1, E1. Understood? If you just understand this sign convention, you can do any numerical in your current electricity. If you don't understand this basic concept, even God cannot help you. Leave God. God can easily help you. You just do like this, and your space in between your ears will be filled. Gustav Kirchhoff can also not help you. Okay. So please remember, positive has highest potential when compared to the negative terminal. Okay. So from here to here, when you are going from negative to positive, potential rise. That's why you have taken minus epsilon 1. Right? Now you come here, C dash to D. So here VC dash is greater than VD. That's why your current is going in this direction. Right? Here VD dash is greater than VD, isn't it?
Yes, sir.
V dash minus VD should be equal to I4 R4, isn't it? Yes. So VD minus VD dash will be minus I4 R4.
Yes, sir.
Yes.
Here to here you see this is positive of the battery, this is negative of the battery. You are going from higher potential to lower potential drop. So VD dash is higher than VA. So VD dash minus VA is epsilon 2 positive.
Can you repeat the last one?
Understood? See, you are going from positive terminal to negative terminal to reach A. Because your loop is A, B, C, C dash, D, D dash, A. You have to start at A, you have to end at A. Understood? So, D, D dash, you understood?
Yes, sir.
When you come to D dash, this is a positive negative terminal. Okay? So, positive terminal potential is greater than negative terminal potential. So obviously you are going in the direction of potential drop.
So it's positive.
Understood?
Yes, sir.
So it will be positive, no? Remember one thing. Guy is jumping from, okay, positive. Guy is trying to greater heights, negative. Here, energy is not required. This guy just can jump. Here, energy is required. He has to perform some work on the system. Right? Performance of work on the system is negative. Here, no work is done. This guy can eat. So that's why it is positive. Okay?
Yes.
So, when a charge wants to go from negative to positive, since positive terminal potential is greater than negative terminal, extra work has to be done, right? That's why work done on the system is what? Negative.
Negative.
When you are going from negative terminal to positive terminal, okay, you will take your direction to be negative. Understood? Now take your previous year capacitor questions, apply the same concept there. In less than 2 minutes, you'll solve those questions. Clear? Because this, I waited for you to tell this, the same concept works there. That's why I told you potential drop and potential rise. Or else, most of the faculty will say, if you are going in the direction of current, take positive, opposite direction of current, take negative, they will say. Clear? So you are going from A to B, you are going along the direction of current, so positive. You are going along the direction of current, so positive. Here, you are going in the opposite direction of current. Again, when you come out, you are going in direction of current, in the same direction of current, so positive. Here you are going in opposite direction of current, so I4R4 is negative. Clear? Now you get confusion. Sir, if I3 is going like this, okay, from battery here only charge is going, no? So from here to here also I'm going in direction of current only, no? So half-brained concept will not work. Understand? So it is your single thing. Potential drop is
Negative. Positive.
potential rise is
Negative.
negative. I clearly told you potential rise. That means charge is going from lower potential. Can it go by on its own?
No, sir.
Can it go from low pressure to high pressure on its own?
No, sir.
You have to perform work to do that, right? So potential rise is always taken as negative and potential drop as positive. Remember this small sign convention, you will be able to do anything numerical. The same concept of your junction law and your loop law can be used in your capacitors, the circuits of capacitors. Okay, now you try to solve your capacitor problems, it will be very easy for you. Clear? Now let's see put your heading as cells connected in series. If two cells are connected in series, this is called as your grouping of cells. The model heading will be grouping of cells, and below that we'll put it as cells connected in series. I'll tell you this next time. Now just remember, the current is coming from epsilon 1. This is your resistance. It is going like this, and it is going into your epsilon 2 and then coming from here. So if you see, same amount of current is exiting a battery and entering another battery, right? Is the current different?
No, sir.
It is not, right? Now for this, applying loop law, A, B, C, D, E. Applying loop law for A, B, C, D, E, A. Remember, you are starting at A, you are ending at A. So start at A, go. Tell me your equation. Assume this has an internal resistance R1 and this has an internal resistance R2. Your internal resistance, if you want battery, you can take it as small resistances placed here, R1, R2. Now you tell me what is done. Use your loop law. The current is going from A to B, and see the current is going. So it is a potential drop or potential rise.
Potential drop.
Potential drop.
So can I say it is I into R?
I into yes.
Come here, D to this point. Potential drop or potential rise?
Drop.
Drop.
So
Plus IR2.
Yeah.
from here to your potential drop or potential rise?
So minus epsilon.
So it came like this, from here to here, potential drop or potential rise?
Potential drop.
Potential drop.
So plus I R1, from here to here, potential rise or potential drop?
Rise.
Potential rise.
So minus.
To 0.
Yes, sir.
From this, I take in common plus R2 plus R is equal to epsilon 1 plus epsilon 2.
Sir, IR2 is from where to where?
From D to this cell. Clear? So comparing above with epsilon naught is equal to IR naught. So what is your effective EMF?
E1 plus E2.
Is epsilon 1 plus epsilon 2. What is your effective resistance?
R1 plus R2 plus capital R.
Effective is R plus R1 plus R2. Now what they'll ask is, anyhow you know this, write it as effective internal resistance. How much?
R1 plus R2.
R1 plus R2. Clear?
Total resistance is external plus internal.
Now see, if your resistance is not there, then the current will not come out of the battery, right? Current will be only going inside the cell from negative to positive. So if I need the potential difference between cell 1, can I say it will be epsilon 1 minus IR1?
Yes, sir.
And potential at cell 2 will be epsilon 2 minus IR2 when no external connected.
Yes, sir.
Okay. So from this, we come to know that your potential difference formula is epsilon minus IR. Okay, remember that. Understood? Now, if somebody asks you what is the total current flowing through a circuit in series combination of cells?
Total internal resistance.
Total current I is equal to epsilon 1 plus epsilon 2
Divided by R1 plus
R1 plus
R2 plus
R2.
R.
plus R2. This is the total current which is passing through your circuit. Right?
Yes, sir.
Now, if your polarity is reversed, that means I said the batteries are connected in this way, isn't it? If this is how your battery is connected, you got this formula. Now, imagine if the battery is connected like this, polarity reversed. Then what would your formula become?
E1 minus E2, meaning epsilon naught minus.
Yes, note if polarity is reversed, your effective EMF will be modulus of epsilon 1 minus epsilon 2. Now, if I take 6 volts battery and 6 volts battery connect like this, what happens?
There's no effective epsilon.
If there is no effective EMF, what happens to your current?
No current.
No current.
This is the reason why your parents will tell you, I take that remote, reverse the battery and put. So don't think you know more than your parents. At least your parents know how to do things, they don't know technicality of it, but they know things. They may not be able to explain, that doesn't make them not knowledgeable. Clear? Now, since you are studying this, for everything your parents say, now you know the reason. Now you will say, you know why you are telling like that and what happens. You tell them, if you reverse the battery, so this is like the effective EMF is mod of epsilon 1 minus epsilon 2. Since we'll be using 10 volts battery, 10 volts battery, 10 minus 10, 0. No current is flowing, so your remote is safe. Clear? Next, cells connected in parallel. How do you do it?
Previous junction.
Cells connected in parallel.
Junction.
See, I'm taking the internal resistance as a small resistance, okay? This is not external resistance. These are resistances, okay?
Yes, sir.
This is your external resistance. Okay. Now, assume that there is a current I going in your resistor. Okay, it comes here. Let me say I1 goes into this, and then I minus I1 will go into this.
Yes, sir.
Do it. How do you do it? Okay, now see, this is how you consider a loop. It should always be a closed loop. So I'll take this as A, B, C, D, E, C. This I'll take as D dash, this I'll take as E dash, and this is F. Can I take loop A, B, C, D, E, F, A?
Yes, sir.
Use your loop law. A to be potential drop,
IR.
so D to this one is also potential drop.
My plus I1 R minus E epsilon 1.
Question 1. Sir, you have told us the loop law before. It's very simple. For this,
IR plus I minus I1 into R2 minus epsilon 2.
clear?
Yes, sir.
Do it. You have to get in the form epsilon effective is equal to I into R effective from these two. This I write as IR plus IR2 minus I1 R2 minus epsilon 2 is equal to 0. So 2 I multiply 2 with R1. So this will become IR R1 plus IR2 R1 minus I1 R2 R1 minus epsilon 2 R1 is equal to 0. Right? Let this be equation 3. Multiply 1 with R2. It will be IR R2 plus I R1 R2 minus epsilon 1 R2 is equal to 0, is it?
Yes.
I1. Let this be 4. I'll add 1, 3 and 4. 3 plus 4. Right? IR R1 plus R2 plus I R2 R1 minus epsilon 2 R1 minus epsilon 1 R2 is equal to 0, isn't it? Hello?
Yes, sir.
So I find R into R1 plus R2 plus R2 R1 is equal to epsilon 1 R2 plus epsilon 2 R1. Is it?
Yes, sir.
So I is equal to epsilon 1 R2 plus epsilon 2 R1 divided by R into R1 plus R2 plus R2 R1, isn't it?
Yes, sir.
I'm dividing numerator and denominator by R1 plus R2. So this will become epsilon 1 R plus epsilon 2 R1 divided by R1 plus R2 whole divided by R plus R1 R2 divided by R small r1 plus small r2. Isn't it? This is in the form of epsilon effective divided by R plus R effective. Therefore, your effective EMF is
Epsilon 1 R2 plus epsilon 2 R1 by R1 plus R2.
clear, and your effective internal resistance is
R1
R1 R2 divided by R1 plus R2.
by R1 plus 1 by R2.
if your epsilon 1 is equal to epsilon 2 is equal to epsilon and R to R2 is equal to R, what happens to your effective EMF? That means if I take two cells of 10 volts and 10 volts, and if I connect them in parallel, what is your effective EMF?
2 epsilon by r.
Is
2 epsilon.
and R1 is equal to R2 is equal. E effective would be equal to epsilon
Epsilon naught
plus epsilon R
by r plus r.
Clear? So whenever you connect your cells in parallel, now you understand why we take potential difference as constant when your capacitors are connected in parallel. What about your R effective?
R by 2.
R by
2.
Clear? This goes into your formula, okay? Cells connected in parallel. The effective EMF is epsilon 1 R2 plus epsilon 2 R1 divided by R1 plus R2. Sometimes they write as, in a different way. Okay, how they'll write it is like epsilon 1 by R1 plus epsilon 2 by R2, right? So this becomes epsilon 1 R2 plus epsilon 2 R1
Yes.
divided by, so since you are dividing it with R1 R2, this also you have divided with R1 R2, isn't it? Yes or no?
Yes, sir.
1 by r1 plus 1 by r2.
Clear? This is nothing but your 1 by R effective. Okay. This also you can remember. Okay. Always in this you also can remember. Clear? Next. Grouping of resistors. Grouping of resistors. Resistors connected in series. Whenever the current flowing through the resistors is same, then the resistors are said to be connected in series. Now tell me what is your R effective for this?
R1 plus R2.
Very easy. Do it. Do it and what is the method to do it?
Loop law again.
Yeah?
Loop law is closed, right? So
Okay, so
It'll be IR plus IR.
Okay. You can either go for your loop law or the method which I want you to do is consider the potential here as V1. Consider the potential here as V2. There is a reason why I'm telling you to do it. Okay. So can I say potential is V1 plus V2?
Yes, sir.
So V1 is nothing but IR1 plus V2 is nothing but IR2 is nothing but your I into R effective. So from this, R effective is equal to R1 plus R2. This is not I'm interested because you already know. What is your potential V1 in terms of your total current? Tell me. Your total potential in terms of R1, R2 and your V. What nonsense is this? R1 divided by R1 plus R2 into V. My goodness. Capacitors you have done no, ma? Capacitors connected in series. Potential difference across the capacitor.
R2 by R1 plus R2.
So V1 is nothing but IR1, but I is nothing but V by R effective into R1. Yes. So V1 is equal to R1 divided by R1 plus R2 into V. V2 is equal to R2 divided by R1 plus R2 into V. If you take a ratio, V1 divided by V2 will be in the ratio of R1 divided by R2. Okay? Understood? See, this is why I want to, this is what I'm interested. Because in your numerical, this is what they'll ask. What is your potential across resistor, potential across this one? Immediately you'll use this formula and you will solve it. Clear? Parallel combination. Don't tell me the answer. Draw a diagram. Derive it. Get me your I1s and I2s now. One will tell me I1 and I2 in terms of R1 and R2. So let me say there is a current I1 going into this and there is a current I2 going into this. So your total currents is the combination of individual currents, right? So V by R effective is equal to V divided by R1 plus V divided by 1 by R effective is equal to 1 by R1 plus 1 by R2 and so on. Now I want current 1 going in your resistor 1 is how much?
So will it be like R2 by R1 plus R2 into I?
What will be your I2?
R1 divided by R1 plus R2 into I.
How do you get this?
Capacitors.
Your I1 is nothing but V by R1, right? Yes or
Yes.
no?
Yes, sir.
But I know V is equal to I are effective,
Yes, sir.
isn't it?
So I into
So
1 R1 plus
it will be I into R1 R2 divided by R1 plus R2. So your I1 will be equal to V divided by R1. V is I into R1 R2 divided by R1 plus R2. R1 gets cancelled. From this, I1 by I2 is equal to
R2 by R1.
currents are in the inverse ratio of your resistors, and your potentials are in the same ratio of your resistors. Remember that.
So we can get the same thing by V is equal to IR also, right?
Done. I still need to tell you Wheatstone bridge, meter bridge, and potentiometer. And then your galvanometer. Conversion of galvanometer into conversion of galvanometer into voltmeter. Nikita, until which day do we have current electricity
1 minute, sir.
schedule?
Yes, sir. 1 minute. So we have current electricity, like they have given us the end of the schedule for 10th June, sir. Till there we have current electricity only.
Next week also you have current electricity.
Yes, sir. Next week we have Kirchhoff's law, circuit problem resistance, Wheatstone bridge, conversion of galvanometer into ammeter.
And Sensage also. And next week full week we have
Yes, sir.
electricity will go deep. I have enough time.
Yes, sir.
Okay. Okay. Doris question. I want to tell the answers of this question. First, we'd like to implement it.
I couldn't even like figure out the formula. You have to check the hints. I could like
mind is favoring something. I don't know what in this direction it is. 5 into 10 power minus 11 meters is the radius of the orbit, and the speed is given as 2.2 into 10 power 6 meters per second. And the electron is revolving around the hydrogen nuclei. We know I is equal to Q into T. Q is an electron, right? One electron is revolving. So it is E into T. So T is nothing but 2 pi by omega. Right? Which is equal to 2 pi divided by omega is V by R.
V by R.
Which is 2 pi R by V. See how beautiful, what should I say? Synchronous is your, physics. 2 pi R is distance divided by speed gives you time. Physics has harmony in it. 2 pi R is your distance, no? And V is your speed. Distance by speed again time. Have you hit I like see again coming to the basic fundamental formula. So this will be E into 2 pi R by V. Substitute your values. There are certain students who don't know the charge of an electron, mass of the electron, mass of the proton. I don't know what they are studying also.
Sir, I got 1.12 into 3 ampere.
No, I don't know. I have to check the answer. Divided by your velocity is 2.2 into 10 power 6. So I'll take 22 by 7, you can take. 22 by 10 gets cancelled, 10 goes up, 10 squared takes 7 is there, 7 1 7, 7 2 is 14, 27, 4. Approximate. How much you got, Amma?
I got 1.2 into 10 power minus 3.
Clear 1.2.
I'll check once again, sir.
Right. 22 by 7. You are getting 2.
Sir, I is Q by
2 by
T.
T.
Yes, sir. Q by T.
You took QT. I is equal to Q by T.
By T. See, I have done a mistake. E divided by 2 pi R by V. So EV divided by 2 pi R. Did you study Bohr magneton and all that? Chemistry? Anyhow, do it. Now then you will get, I think, 1 point. How much?
1 2.
1.2 into 10 power minus 3 ampere.
Add this, you will do easily. Okay, take it down. I forgot to tell this. D, mobility mu. Draw a line and take it down. Mobility, electron mobility. Electron mobility. In brackets, mu. In brackets, mu. It is defined as the average drift velocity. It is defined as the average velocity when unit electric field strength is applied, when unit electric field strength is applied, when unit electric field strength is applied. So mu is equal to Vd by E. Okay. That I forgot to tell you. So, do this question.
So mu is equals to
Vd by E.
What's your answer? The temperature coefficient,
25 degrees Celsius.
how much?
Approximately 25.5.
Okay. The temperature coefficient of resistance is given at 0 degrees Celsius. Find the temperature at which the increase in the resistance of platinum wire is 10% of its 0 degree Celsius, right? So R is equal to R2 is equal to R1 into 1 plus alpha delta T, isn't it? So delta T is delta divided by R1 alpha, isn't it? Hello?
Yes, sir.
0.1 R divided by R into alpha. So 10 power minus 1 divided by 3.9.
10 power minus 3.
Take it approximately as 4. So 0.25 power minus
10 power 2.
25 approximately is your delta T, isn't it?
Yes, sir.
So he's telling that T2, so T2 is 25 degrees, correct? Next, do this question. I should not have given in between the dx element and everything. Without that element, you take it. Okay. So your initial diagram would be something like this. Here to here, the distance is b. From here to here, distance is a. So, like this will be your initial diagram. See, I have given already. Take a small element dx, thickness is dx, whose radius is y at this point. For this, if you calculate your dr, d resistance, calculate it from A to B, you will get for the whole thing, isn't it? Yes or no? dr is nothing but rho dx divided by your dA, the area of that, which is rho dx divided by the area is pi y square. Yes. Now this thickness, I need it in terms of your y. So if I integrate it, I will get my answer, isn't it? Y dA, just area only. Correct? Now, how do you calculate its dx? What?
What should
Huh?
we should integrate dx from a to b, right?
Yeah, but see, dx and y square, y is also changing, no? Yes. Y will be from A to B.
So we can take y in terms of a and b, right?
Okay, that's what I'm telling. Do something. What nonsense? How much can you take a small thing? This is one triangle, and this is another triangle. Similar triangles, b minus a by l is equal to y minus a by x.
Yes.
So this will be b minus a by l plus a by no. B minus A is equal to Ly minus La. So this is into x. It will be Bx minus Ba is equal to Ly minus La, isn't it? Axa. Correct? I'm going to differentiate both sides with respect to x. So it will be b minus a is equal to L dy by dx minus this will be L. This is constant, right? So this goes to 0, isn't it? Minus 0. So from this, dy divided by dx is nothing but b minus a divided by L. Instead of doing all these things, see how simple I'll do. I've taken this angle as tan phi. So tan phi is equal to by L. Tan phi is nothing but dy by dx. Why don't you simplify your life? Yes or no? Instead of taking similar triangles approach and everything. So from this, what is your dx?
L by b minus a into dy.
Dy. Substitute that here. dr is equal to rho L divided by b minus a into dy divided by pi y square. So rho L divided by b minus a pi b minus a into dy by y square is your dr, isn't it? So r will be equal to integral a to b rho L divided into b minus a into dy by y square. So rho L divided by pi into a minus b into 1 by y from a to b, isn't it? Correct?
We will get minus rho L by pi into AB. Meaning
Rho L by pi.
by AB.
Rho L divided by.
They'll get minus, right? No, sorry.
Minus.
Understood?
Yeah, minus will be there, sir.
That's going to be minus, no?
Okay.
Amount of the value. Clear? Understood? So tomorrow we'll do some more numericals on your drift velocities, conductivities, resistances of different shapes, like taking a small element and then doing it, and then parallel combination of resistors, cells in series and parallel combinations. Okay, so this whole week we'll solve numeric possible. We'll go to solving problems from Cengage and Miller. Okay. By any chance, at least by mistake, if you got interest and you solve some problems and you don't get it, send me. So we do that questions also. And you stop doing questions. No? You are thinking, okay, I'll do questions when Karthik says send me homework. Okay. Well, let's do one thing. Advanced material, take it down. Complete your CEQs, okay, until this one.
They're giving me a PDF one.
Yeah. Level 1, 1, 2, 3. Level 1, 1, 2, 3. Six, 8, 9, 10, 16, 17, 24, 25, 27, 29, 33, 35. Yeah. Any questions you got?
15 questions plus CQ.
Yeah. So 15 questions. Try to solve those questions. It's a homework. Very easy only. It will take not more than half an hour. After that, you try to solve some more numericals on your own from your material level 1 homework. Clear? So if you don't get anything in these questions, we'll solve them.
Yes, sir.
Yeah. See you today. We don't have any doubt session, right?
Yes, sir.
Okay. So I'll see you tomorrow.
Thank you, sir.
Today's meeting
Thank you,
is
sir.